V is the vertical shift. If it's greater than 0, what is it? Up. If it's less than 0, it is down. Right? You understand that? What is phase shift?
C over B.
Phase shift is C over B. And they're both absolute value, right? Phase shift. Everybody okay with that? All right. B changes because for tangent and cotangent only, the period is pi over the absolute value of B. What's different? So pi over the absolute value of B is the period. Okay, so that has changed. Yes? A is now called a stretch or shrink factor. What do you think a stretch or shrink does? If A is between -1 and 1, before I say this, let me make sure I'm right, because I don't like the way the book words it. Have you just had enough?
Oh yeah, I had. It does feel good. I was holding my breath the whole time.
It shrinks it. Otherwise, it stretches. What does it mean by shrink? Squishes it down. Stretch pulls it straighter. Okay? So it stretches if A is less than -1 or A is greater than 1. All right? The book goes through all this long story about it. So I was trying to make it as simple as possible. All right. That's tangent and cotangent. You ready to graph one?
Yes.
How did you do with your scale? Okay? You did okay with your scale on yesterday? You're kind of figuring that out, how to work it? All right. You want to, let's do a fairly, well, let's do this. Let's put this. Let's do just a y = tan of x. your calculator. What's the period? Pi. Right? So what is the next scale? Pi over 4. Right? Do you all have it? Where is an asymptote?
Oh, wait, not pi over 2. Just no. Wait. Yeah, it is pi over 2. Yeah, it is pi over 2.
I think it's pi over 2. So it looks, an asymptote here, I think, don't have a point at 0, 0?
Yeah.
What is the tangent of pi over 4? Remember when we did our 45, 45 triangles? This was pi over 4, this was 1, 1, radical 2. So the tangent of pi over 4 is 1, which shows up on our graph. And I believe the tangent graph looks like this, doesn't it? And then over here at 3 pi over 4, wasn't it negative 1?
Yeah.
Why would that be? What quadrant would 3 pi over 4 be in? Second quadrant, isn't it? And tangent is what? Tangent is negative. And it is, isn't it? And here I believe it's 0. So it looks like this. Right? Do you agree? Now, just out of curiosity, you have in your calculator y1 is y equals tan x, don't you? I would like you as y, leave that there, and as y2, put in 5 tan of x. When you put in as y2, y equals 5 tan of x, I want you to look at the difference in the two graphs. See how much it stretched it? It just kind of pulled it out, didn't it? That's what that 5 does. There is no amplitude for tangent. You okay with that? You could. You could. All right. Now, that's tangent. Let's talk about what cotangent looks like. So clear those out. Let's graph y equals cotangent of x. What's the period? Chandler, how come they make you answer all the time? Nobody else is answering. Oh, you were thinking. Sometimes it's hard to answer and think at the same time. It is. You just need a minute to process it. So my scale is still going to be pi over 4, isn't it? It's okay. That means you're doing it with me. And some people work better if they're audio with it, if they're speaking it, and some are not. Do you have it on your calculator? Well, it is the same thing, except Isn't it, are the asymptotes different? Where's an asymptote? Do you see an asymptote on your graph? There is one on each side of it because it shows you the whole graph. So basically, there's an asymptote here, and there's an asymptote here. Can you realize they're there even though you don't see them on your graph? Because you're at the ends, right? Now, if tangent of pi over 4 was 1, and that's a good thing for you guys to remember, that tangent of pi over 4 is 1. What is it, cotangent? The reciprocal? So what's reciprocal? 1. So at pi over 4, cotangent must be 1. At 3 pi over 4, tangent was negative 1. So what is cotangent? Negative 1. Right? Now, your calculator is not as smart as you are. Because trace, what's between those two, pi over 2? Trace pi over 2. Did you? And what does it give you? Nothing. Nothing. And the reason it gives you nothing is because wasn't tangent an asymptote there? And all your calculator is doing is taking the reciprocal of tangent. And it doesn't know how to take the reciprocal of undefined. You do. Because isn't this number undefined? 1 over 0. So what's the reciprocal of that? 0. So it actually has a point right there. So you see, you all are smarter than your calculator. Or at least smarter than the person that programmed it. They just didn't program to flip over undefined. And that can happen on secant and cosecant, or when you do some, but those are reciprocals. This is the one where you're going to see it. Tangent and cotangent. If we were doing the others by hand, we would see it. Doesn't it look something like? Remember, it goes to the asymptote, but doesn't cross it. So that's going to be a little bit of a trick when you go to graph 1. Because your calculator cannot flip over undefined. Isn't that what it's doing? Flipping over tangent? Okay. So, are we ready to do a hard one? I would like to do a hard tangent, and then we will do a hard cotangent. All right? Is that all right? All right. Excuse me. Y equals 3 tangent pi x plus pi minus 2. Right off the bat, the period is 1. Do you agree with her?
Yeah. I thought the first bit. I thought it was
Okay. So that means I'm graphing to 1, doesn't it? What is your x scale? what you said? 1/4. I like fractions better than decimals. Because when you grow up not ever using a calculator, fractions are much easier by hand than decimals are. Much easier. Huh?
I like whenever I'm not using a calculator, fractions are easier.
Way easier, yes. 1/4. Right? Everybody agree with that? Okay. I have a phase shift of 1, don't I? And I have a vertical shift of what? No, down 2. Down 2. Okay? Tell him to go away. I only have to put up with him once a day. And I just put that. That's the middle of the graph. That's why I put that. All right? Where is an asymptote?
Number 2.
What is 1/2?
5.
1/2?
Oh, 1/2. Yeah. I'm like, did I move wrong?
1/2 is an asymptote, right? Did you all agree with that one? Oh, you're not there? When x is 0, what is y? -2. When x is 1/4, what is y? 1. And so I'm assuming, which way does it go? Up. Well, I know, but I didn't know if it went up like this or up like this. See how that makes a difference? There we go. Does it look like that? All right, I need another point. How about 3/4? Okay. And 1. It better be back where I started, hadn't it? Because we're doing 1 period. So does it look like this? That's going down? Is that what it looks like? Does that make sense? All right, ready for a hard one? You would love a hard one? Is that what you said? I knew you would love a hard one. There's the period.
Oh, that's an X. 2 pi.
That's next. 2 pi? You sure? Okay, some people are frowning at me. I'm letting them think of it, guys. Are we okay with it being 2 pi? Well, isn't this x over 2, isn't it the same thing as 1/2 x? So b is actually 1/2. So I have pi over 1/2. Does that help to look at it that way? I don't think he got it first that time. All right. So my period is 2 pi. What is my scale? What's my phase shift? How about that? What's my phase shift? Okay. Isn't the phase shift pi over 2 over 1/2? Isn't it? Don't these two cancel?
Yep.
So what is the phase shift?
Pi.
Pi. Did that help to see the math part of it? Okay. So we agree the vertical shift is 1 up, don't we? The phase shift is, excuse me, pi. The vertical shift, we did it. The period we said was what? 2 pi. Okay. So, in my calculator, what is my window? What is my x minimum? 0. What is my x maximum? 2 pi? What's my x scale? Which is what? No. Pi over 2. We've been doing 2 pi divided by 4 for 2 weeks.
I knew it was pi over 2, but like, I just
It just didn't come out the way you wanted it to, did it? Okay. 1, 2, 3. All right. When you graph it on your calculator, do not put the +1 in the denominator. It does not go with the angle, right? Is yours in?
Yeah. Good.
I was looking to see if you could see an asymptote. You kind of can.
Yeah.
You zoom out, you lose your 1 period. Where is?
So what the zoom button does?
Yeah.
I have no idea. I just always expanded. What is it?
and then you
The
see
window values. Yeah. Yeah, me too.
if you don't move your
I like your
Oh my god.
So it helps you see that asymptote.
And then zoom out.
and then click down to zoom out. Oh,
I
and
know.
it'll zoom out, and then you do the exact same thing. If you don't move from the point thing, it'll zoom back in the same for yourself.
Okay, so where's my asymptote?
Pi.
Pi. Right here. Okay? I've got a problem, guys. Because if I plot, I only have 1 point here to plot. So I have to be really careful. I've got to make sure I plot 0, don't I? What's 0? 1? Does that show up on your calculator?
You have to change the window, but yeah. If you change the window to your x window was -1, then you plug in, and then if you put trace and zero if you want. It won't trace the point, you can just see it.
No, yeah, you can just see
You
it.
just see it. It won't let you trace 0?
Not if it's not if it's
Trace zero.
I traced 0 and it gave me
I just moved the little X.
Well, but remember, it's cotangent, so it's flipping tangent upside down.
Exactly.
So,
Yeah, I got 0.
yeah, so you guys have to be careful on cotangent, because it's flipping tangent over. So you're gonna have to look at the graph some too, and not just trace. So you think it's 1? Okay, what is pi over 2? Does it say 0? Okay, I didn't know if it was giving us a funny thing there. So does it look like this? So do I have an asymptote. My next one is 3 pi over 2. What is it? 2? And then I better be back to 1, hadn't I? So it looks like this. Agreed? Okay.